I just really need help with calculus. Now, what is calculus anyway? You know, I just really need a lot of... Hey, whoa. Malek, what are you doing here, buddy?
Oh, hey.
How's everything going?
What are you doing here?
What are you doing in my house?
Oh, my bad. I forgot. I don't know.
Well, I mean, I need some help with calculus. I'm not sure if maybe you can help me.
Calculus?
Yeah.
Really?
Yeah.
It's interesting because I was actually looking to give a calculus lesson.
Really?
Yeah.
I guess I'm in luck then.
I guess you are.
Wow.
Well, how about we go look for a problem?
Oh.
Do you think we can find one someplace?
I don't know. Maybe we can.
Let's go look. I don't know. Maybe we'll.
Okay.
Look here or something.
Yeah, sure.
Hey,
Well,
what's that over there?
What the? That's a tripod and a calculus problem.
What do you know?
You know what that means?
I guess we're in for a lesson.
Wow.
So it says, find the volume of region R given that y equals negative x plus 6, y equals 0, x equals 0, and the region is revolving around the x-axis. Well, I think, Brian, if we're going to start off, we need to understand some pre-calculus concepts. We have to know how to graph, first of all. We have to know how to graph a line. We need to know how to graph this line, as well as this line. And we need to know basic English language so that we can understand what revolving around the x-axis means.
Right.
Let's start by graphing this sucker. Right? Which, like I said, requires some basic knowledge of pre-calculus mathematics.
Right.
So, this graph will look like this. This is x equals 0. Or excuse me, y equals 0. X equals 0. And this is our region right in there, where that little triangle is. Now, we want to first of all solve for these points. These little points of intersection. Because those values will be the limits of our integration. Alright? You following along, Brian?
Right.
Alright. So, what we're going to do is we're going to set up our formula. So it's going to look like this. The volume will equal the, first of all, the pi times the integral of those endpoints. Squared. Now it's a little hard to read, and I'll move it up in a second.
Right.
Right now you can see the gist of what's going on. We have pi times this is the outside radius squared minus the inside radius squared. And this formula comes from this formula, this very familiar formula. Volume equals pi r squared.
Right.
Here we have the pi, here we have our radius squared, our outer radius in this case, and our inside radius.
Wait, your radius or my radius?
Our radius.
Our radius.
I can just tell you right off the bat that the endpoints are 0 and 6. Alright, so I saved as a step. Normally what we would do is we would set the equations equal to each other and solve for where they intersect. I've saved us the time. I just did it in my head, and you can take my word for it. Does that sound okay, Brian?
Yeah, it sounds like Mr. Miller.
So, volume will equal pi times outside radius. So now we start from where the axis of rotation begins. In this case, it starts right here. Okay, this is where we're rotating from. So we're going to start there and work our way up. And we're going to go as far as we possibly can within the given limits of the area, of the region, excuse me. And in this case, that'll be this line, which is negative x plus 6 squared minus. Now, what's the inside radius, you ask? Well, here's where it gets a little tricky. It's not really tricky, it's actually very straightforward. We start here, and when we start at this axis of rotation, we're already at the inside radius. So in this case, the inside radius is y equals 0, or just 0 squared.
Right. Excuse me.
Dx. Forgot the integral. It's not calculus until we have the integral. And like I said, it's from 6 to 0.
Why is that?
Why is that? Well, if we look at our region, it is within the values of x equals 0 to x equals 6.
Right.
Okay. Now, I'm going to rewrite this, and I'll let Brian show you guys how to...
I'll take over from here, Malik. Alright, so here we have a fundamental integral, right? We're going to simply solve what's inside here. Quickly, I'm going to go ahead and expand it. X squared minus 12x plus 36 minus 0, right? That 0 is, so it's basically x squared minus 12x plus 36 integral 0 to 6 pi. Right? That's what we have. We're going to do some fundamental integration. Put it this way, if you don't know how to do basic integration by now, what are you doing, right? What are you doing with your life? I mean, clearly I'm gonna need this for the job. We integrated it now, but now we have don't ever forget your limits of integration. Right? So what we're gonna do here is we're going to plug in the 6, right? 1 over 3, 6 cubed minus 6 times 6 squared plus 36 times 6, okay? And then just make sure that, because I know 0 sometimes cancels everything out, just make sure that it cancels everything out. You don't have any constants or anything like that. So here, clearly, it's going to be a minus 0 because it cancels everything out, so we're just going to worry about this side. 6 cubed, 6 times 6 is 36. When you integrate it, right, you get everything. You plug in the 6, you plug in the 0, 0 cancels everything out, you plug in the 6. You get 72 minus 216 plus 216. So I guess that cancels out, and you end up with 72. Okay? That's your limits of integration, right? Don't forget, you're bringing this all the way down here. So V equals 72 pi. And that's your answer. 72 pi. So just know, you're clearly going to need this. Any profession you're going into, make sure you have this memorized, and you should be fine. Anyway, thank you Malik for helping me out.
Yeah, no problem.
Class of 2017. Thank you, Mr. Mills' class. I really, truly enjoyed this class very much. I just really like Mr. Miller a lot. I think he's a great teacher. I think that I really enjoy his class a lot. All the people there are so nice. Kyle, you're always the only one that knows the actual answer to the question, but you're just so nice, and everyone in there is so nice, and I just really like calculus, and I'm really gonna miss this class.